This is the product rule of exponents. Our first rule is the product rule. And the product rule says if we have two expressions with the same base, then we can just add their exponents. So notice here I have a base of b. I can just add n plus m. For my first example, x squared times x to the fourth, remember this would be like having two x's and then four x's, which is why our rule works, which means total I would have 6 x's. So instead of having to write this out every time, we can just add the exponents to find out how many x's total we have. For my second example, 2 to the first times 2 to the second, 1 plus 2 is 3, so my answer is 2 to the third. And for a number, I'll go ahead and evaluate to find 8. Try these two on your own, then press play to see how you did. For my first example, I have 3 plus 7, which is h to the 10th. And for my second example, 2 plus 1 is 3, so 3 to the third, which is 27, because remember we're taking 3 times 3 times 3, so 3 times. These examples also use the product rule, but as you can see, now I've included coefficients, meaning values or numbers in front of my variables. So when I'm multiplying with coefficients, I follow the normal rules for multiplication for my coefficients. 4 times 2 is 8. But I use my product rule for exponents by adding exponents of the same base. So I have 6 x's. So I multiply this 4 times this 2, but these two I'm going to add together. For my second example, 3 times 9 is 27. I have 2 x's here and 1 x here, so that's 3 x's total, and a total of 5 y's. Again, try these on your own, so press pause. Once you've completed them, press play to see how you did. For my first one, I should end up with 20, because 5 times 4 is 20. A to the fourth, since there was 1a over here and 3 here, and b to the 7th. For my second example, 15 times 5 is 75. I have 9 x's and I have 6 y's. So don't be concerned here that this one does not have any y's. Just pretend it's a 0. So 6 plus 0 is 6.